Hello, Professor everyone. My name is Kai Chungying. I'm going to present homework number 3, part 1 and part 2. This program could be launched in the IPython notebook by clicking on the cell and click one all the result will be displayed and all the text file will be saved in the same directory as this program file. First of all, we have to import all the libraries and then split the inaugural dataset into two datasets, pre-World War and post-World War. And then we use the inaugural words function to extract all the words and save to a list, and then use the lower function to downcasing all the words in the list for both datasets. And then we use the frequency disk function to get the frequency of the unigram for both datasets, and then sort the frequency value of the unigram and get the top 200 unigrams for both datasets, and then get the union of the unigram for both datasets by using the set function and save in the list, and then filtering out all the words with equal to 2 and less than 2 in length and all the stop words and print that on the unigram text file. For the bigrams, basically the same as the unigram, but we just need to use the bigram function to get the bigrams and use the frequency function to get the frequencies of the bigram, and then get the top 1000 bigrams from both datasets. And then use the set function to get the union of the bigrams for both datasets and save in the list, and then filtering out all the words with 2 or less than 2 in length and all the stop words, and then print it in the bigram text file. And then also we plot the bigram and its frequency in a bar plot with sorting the probability values. Then we can check out the output text file for the bigrams and the unigrams formats. The next part of the assignment is to calculate the PMI value for the bigrams. We use the function that are given in the assignment to calculate the frequency of the unigram and the frequency of the bigram in the windows of 3 words for the pre-World War dataset and post-World War dataset. And then we save up all the bigrams with the economy words in there, and then we combine all the frequency and the bigrams in a data frame. And then we calculate the PMI value by using the log2 functions on the total counts of bigrams, total counts of unigrams, and total count of work 1 and work 2 of the bigrams, and then combine the PMI values to the data frame, and then filtering out all the words with equal to 2 and less than 2 in length and all the stop words, and then get the top 45 bigrams and sort the value in descending order by PMI value and sort the World 1 and World 2 in ascending order value. After the pre-World War dataset, we work on the post-World War dataset with the same code, and then print out all the PMI and the bigram values in the PMI text file. After that, we work on the extra credit, basically use the values we got above to make a plot, a bar plot by sorting the probability values. And we can check out the PMI text files, output files here. The second part of the assignment is to create a model to predict the next word in the sentence. We use the text 2, 5, and 6 from the NLTK book library. And then we generate the conditional frequency distribution for the bigrams, and then we add in one smoothing by using a Laplace probability distribution. This is the model. We input the conditional frequency distribution and first word of the sentence, the number of words in the sentence, and selection mode. For selection equals to 0, it returns the word with the highest conditional probability associated with the previous word. When selection equals to 1, you randomly pick a word that associated with the previous word regardless of the probability. When the selection is equals to, it select the word based on probability. For this part, we randomly generate a point between 0 and 1, and then adding up the probability associated with the previous word until it reaches larger than the random point. There are 3 conditions for all these cases. When the number of the words in the sentence reaches the preset value, the program stops. When when the next word is a period, the program stops. When there are no conditional frequency distribution for the previous word, the program stops. Now let's look at the output of the model. With slash n equal to 0, with slash n equal to 1, slash n equal to 2. If the slash is not equal to 0, 1, or 2, then warning sentence will coming out. That's all my presentation. Thank you very much.